Hello, beautiful souls, and welcome back to your very own channel that is Study with Azeen. In this video, we will be covering chemistry. So, as we all know, it's already October, so we are going to start with atoms and molecules. Atoms and molecules. So, as we all know, that's October, and mid sessions are almost completed in every school. So we are going to start with this chapter, that is atoms and molecules, which will be coming in your final exam. So let's begin. So in this chapter, we have to study what is atom and what is a molecule. Okay, so we will study atom in detail and we will study molecule in detail, but up to your standard, not in the deep thing like in the what you will study in 11th or 12th. The thing you will study here will be up to the date and up to mark and up to your standard. So what is an atom basically? So before knowing that what atom is, we shall know where did this atom came from. Okay, so ancient Indian and Greek philosophers have always wondered about the unknown and unseen form of matter. That is obviously the atom, because if we will see the desk, we are knowing somewhere, हम जानते हैं कहीं ना कहीं कि इसका अगर हम break करें, there will be an unseen particle जिसको combine करके ये पूरा desk बना. So, तो जो इंडियन एंड ग्रीक फिलोसोफर्स थे वो they were wondering about the unseen form of matter. So the idea of divisibility of matter, like cutting the matter, was considered long back in India, like around 500 BC. BC is before Christ. So an Indian philosopher postulated that if we go on dividing matter, that is pradharth, like if this is a desk, if we will go in cutting, that is pradharth. This desk is the pradharth, and we shall get the smallest particle. Ultimately, a stage will come that when we shall come across the smallest particle of that matter, beyond which the matter, that the particle would not be able to be cutted more than the state of that substance at that time. And he named these particles, these smallest particles that can't be divided further, he named them Parmanu. So Pradharth is the matter and Parmanu is basically atom, which can't be divided further. Like this question is like we say atom, the smallest particle of matter, but we like what are then protons, neutrons, electrons. These are obviously smaller than atoms because these combine and form atom. So the smallest particles are protons, neutrons, electrons, but atom is the smallest particle which has an independent existence. Like proton independently can't exist, neutron independently can't exist, electrons independently can't exist. So atom is the smallest particle of a matter which may or may not can live indivisible. And another in the same era, like around the ancient Greek philosophers, they thought they go on dividing the matter. A stage came across them that they couldn't divide the particle they got further. Okay, the same happened with the Indian philosophers and the same happened with the Greek ones. So they named this undivisible particle as atom, which literally meant indivisible. Okay, Greek philosophers like go on dividing the matter until and unless they reach the particle that can't be divided further. So, the particle that can't be divided further, they named as atom, and which literally mean indivisible. So, but all these things like the Pradha, Pramanu, atom, this was all philosophical considerations, and not much experimental work was done to validate these ideas. So, by the end of 18th century, scientists recognized the difference between elements and compounds and naturally became interested in finding out how and why atom elements combine and what happens when they combine. So what I said, let me let you understand in this in Urdu. So 18th सेंचुरी के ख़त्म होते होते 18th सेंचुरी के इख्तिताम होते होते क्या हुआ, साइंटिस्ट ने देखा कि अरे यहाँ पे तो सिर्फ ये फिलोसफिकल चल रहा है, लेकिन फिर उन लोगों ने क्या किया, उन्हें एक्सपेरिमेंट करना शुरू किया. और एक्सपेरिमेंट करना क्या शुरू किया, उनको ये पता चल गया कि जी कंपाउंड और एलिमेंट में क्या डिफरेंस है. ये हम आगे पढ़ेंगे इनमें क्या डिफरेंस है. इनको ये पता चल गया कि व्हाट इज द डिफरेंस बिटवीन, दिस इज द मेजर डिफरेंस बिटवीन कंपाउंड एंड एलिमेंट्स, and they naturally became interested in how and why these combines and what happens after they combine. So इसके लिए हमें पढ़ने हैं laws of chemical combination, which was like given by, these laws were given by Anthony L. Lavoisier. So these two laws, the laws of chemical combination, these are basically the two laws of Anthony L. Lavoisier. Laws of chemical combination consist of two laws which are about chemical combination, and these were put forward by Anthony L. Lavoisier. So the first law is like this: law of conservation of mass. Here are two things that we need to understand: that what is conservation and what is mass. We all know what is mass, the weight of an object, isn't it? Conservation. What is this conservation we must be fighting? So here conservation also means quantity and mass also means quantity. This law states that the mass of the substances before and after the change or reaction is constant or same. For example, if I take a beaker or something, a beaker like here. I took a beaker, I put some NaCl and AgNO3. You don't need to know what are these. NaCl, that's common salt and argon. So if I put this in this and I just put this like a lid over it and I weighed it, I measured it, what is the weight of it. For example, it's X gram. Okay, and I just mixed it by tilting, shifting it here and there. I just mix it and a chemical reaction happened there, and then I measured it again. That was also X gram. So this means in a chemical reaction, the mass of the reactant is always equal to the mass of the products. These are reactants which are going to react, and the product, what we get, NaCl will be converted into AgCl and AgNO3 will be converted into NaNO3. And this experiment was really done by an scientist named Landolt. The experiment was named H-shaped test tube experiment. This experiment was named like this because the beaker he took was in a shape of H, like flask. These are the lids. In one side of the H, he kept NaCl, and in the another he kept in AgNO3. And then he mixed it, tilted it something, and this was converted into NaNO3, and this was AgCl or anything, AgCl, and this is okay. So he saw that if before the reaction the mass was X gram, and after the reaction the mass was also X gram. It is in the case with the nuclear in the chemical reactions. Here is an exception. They're like the mass remains conserved every time a reaction happens, but there is an exception, that is a nuclear reaction. Why there is an exception of a nuclear reaction? Because the mass is converted into energy, because lots of energy is released. That's why nuclear reaction mass doesn't remain conserved, it changes. So this was all about the atom's history and how was atom like, and atom was created, atom was explained, and this is what the first law of conservation of chemical combination was explained, and it was given by Antony and Lavoisier, and it was experimentally proved by Landolt, and much more we read in this. So this second law is law of constant proportion. What is this constant in proportion? This was put forward by J.J. Proust. Constant proportion. Constant proportion. This deals with the composition of different, sorry for my handwriting, different compounds. I really try hard to write neat, but I don't want to make the video long so that you can get bored by writing. Like, I can write neatly, like, see, composition. Like, I can write, but it will take more time. The time I will take to write this I have to give this. I don't want to bore you simply, so I'm boring you right now giving lecture. But let's move forward. And if you want notes of these, tell me in the comment section. Then I will provide you the notes with the notes. And this, the statement of the law is, irrespective of the formation of the compound, it will be composed of the same kind of elements and in a fixed proportion by mass. What does this statement means? You will be asking this. Okay, let's go. Let's explain this. This statement states that irrespective of where the compound is formed. For example, if we are talking of H2O, that is water. If it's H2O, irrespective, मैं इसको कहाँ से उठाऊँ? मैं एक साइड से अमेरिका से उठाऊँ, एक साइड से इंडिया से उठाऊँ, एक साइड से दुबई से उठाऊँ, ठीक है ना? एक साइड से कश्मीर से उठाऊँ, ठीक है? टेस्ट डिफरेंट हो सकता है, ये मीठा हो सकता है, ये कुछ और हो सकता है, ठीक है? इररिस्पेक्टिव हम पानी कहाँ से ला रहे हैं? अमेरिका से ला रहे हैं, दुबई से ला रहे, कश्मीर से ला रहे, इंडिया से ला रहे, नो मैटर हम कहाँ से ला रहे, बट जो इसकी कॉम्पोजिशन होगी ना वो हर जगह सेम ही होगी, वो H2O ही होगा, उसमें हाइड्रोजन के 2 एटम्स और ऑक्सीजन का एक ही एटम मिला होगा, तब जाके वो वाटर बनाएगा, चाहे फिर वो अमेरिका से लाया गया और दुबई से, इंडिया से, या फिर हमारे कश्मीर से. सो H2O, यहाँ पे हाइड्रोजन के 2 एटम्स मिल रहे हैं, हाइड्रोजन इक्वल्स टू 2 एटम्स एंड ऑक्सीजन इक्वल्स टू 1 एटम. एंड अगर आपको अभी तक 20 एलिमेंट्स के एटॉमिक नंबर, एटॉमिक मास नहीं याद किए, तो I recommend you just go and learn it, because it's really gonna help you in the higher studies or in this chapter or in another chapters. The structure of the atoms is really gonna help you. So go and learn today 5, tomorrow 5, it will become 10, 5, 5, 5, 5, 5, 5. You don't need to learn 108 elements. Just like learn 20 today, and sometime learn 20 more, and sometime like 20 more. Like first 20 are enough for you for this time. Okay, let's move ahead. Hydrogen, the atomic number of the hydrogen is 1, but here are 2 atoms. So, and the like it's 1 hydrogen, atomic number is 1, and atomic mass is also 1, but here are the 2, so atomic number will be 1. I'm just doing it 2. Atomic number of the hydrogen will be same, but the atomic mass will be changed because there are 2. So hydrogen is 2, and oxygen, the atomic number of oxygen is 8, and the atomic number is always double of the atomic mass. Atomic number. Atomic number is where this oxygen lies, like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, like 6, 7, 8. So here is 8. So that's why I said you to learn these. So 8 plus 8 is, I guess, 16. Let me check whether I'm correct. Yeah, I'm correct. It's 8 plus 8 is 6. So its atomic mass is 16. So we can write it like 2 is to 16. 2 1 are 2, 2 8 are 16. So it's all the composition of H2O is everywhere 1 is to 8. Where 1 is hydrogen and 8 is, what is this? Oxygen. Okay. The composition of the oxygen everywhere in the world is 1 is to 8 by mass. The law defines that the law of constant proportion was put forward by J.J. Proust. The law deals with the composition of different compounds. The law states that irrespective of the source or the formation of the compound will be always formed of the same type of elements, that too in a fixed proportion by mass. This is all that I just make you understood, but it's like English. Okay, so I hope you understood all of the topics of today's. If not, please tell me in the comment section. I will just reply to your doubts and make sure that you got it fully understood. So don't forget to like, share and subscribe my channel. Please send it to your relatives, friends and family to see my way of teaching. If you like it, go and like it. Bye bye.